Okay, welcome back. Today we're going to be diving into 2.5 solving literal equations. So we've solved multi-step equations, we've solved equations with variables on both sides. Now we're going to solve the last type of equation that we're going to talk about, and it is literal equations. So literal equations, the only difference is now here, all if I have 3x minus 5 equals 4, we only have one variable. If we have a literal equation, you might have one, two, three variables in an equation. I'll ask you to isolate or solve for one variable. So for literal equations, we're not going to have, an answer of x equals 5 or x equals 3. It's going to be more of, a variable that's equal to an expression. Okay, so let's go back and talk about our skills that we've learned. We go ahead and solve multi-step equations. So when we go ahead and solve a multi-step equation, we're going to draw a river, and we want to move everything away from that x. So the first thing we're going to do is add 5 to both sides. Okay, and we're going to have 3x equals 4 plus 5 is 9. Last step, we're going to divide both sides by 3, and I'm going to have x equals 3. So that's just a regular multi-step equation where I have a variable that's equal to a number, okay? But we're going to use those same steps. But when we have a case of adding 5 to both sides, that 4 might be a letter, right? Um, or another term. So we might not be able to combine those. So we're going to have to write it as an expression. So that's what a literal equation is going to look like. Excuse me. All right. So now for the first two. The first two, we want to isolate for what variable? Y. So what I want to go ahead and do is let's just highlight that Y. Okay. I want to highlight that Y. Now I'm saying, okay, I want to isolate that Y or solve for that Y, which means my final answer is going to have Y equals something. Okay. Now what side is the Y on right now? It's on the left side. Okay. So if my Y is on the left side, I want to move everything over to the right side. And I'm going to solve it the same, but basically I'm just going to move some things around and simplify. So now the only other thing that's on that left side is the 3 and the x. Now when we're dealing with literal equations, we kind of want to move everything over as is. So here we have 3x. What is that 3x doing to the left side? It's adding, right? So if it's adding to the left side, how do I move that over to the right side? I have to take that whole term and subtract it. Okay, good. Now, when I go ahead and simplify, 3x minus 3x is just 0, and I'm left with y equals what? Now, I have 10, and I have a negative 3x. Now, normally, I would be able to combine those two and simplify and solve for y. But now, 10 and negative 3x are not like terms, so I cannot combine them. So simply all you're going to do is write what it says, 10 minus 3x, which is 10 minus 3x. Okay? And now I have y by itself. Okay? And once I have y by itself, I am done, and that is my complete answer. Okay? Good. Now, make sure that if there is a number in front of y and we divide it, make sure everything's simplified um, in the last step. Okay, cool. Let's try another example. Draw my river. Go ahead and highlight that y. Okay, cool. Now, this is important to understand what you're solving for, because in the next example, I'm going to say solve for x, but these examples, I'm still saying solve for y. Good. Now, where is y right now? It's on the left side. I want to move everything else to the right side. Good. The only other thing that's over here is that 10, negative 10 rather. So how am I going to move that negative 10 to the right side? I'm going to move that negative 10 by adding 10 to both sides. Adding 10 to both sides. Okay, cool. Negative 10 plus 10 cancels out to be 0, and I'm left with y equals negative 2x cannot combine with positive 10. Now, watch how I don't write it directly under that negative 2. x. I don't write that 10 under there because they're not like terms. I can't just add straight down or subtract straight down. So I'm just going to write negative 2x plus 10. Once my y is isolated, I am done. Okay? Cool. Alright, so let's try another type of example. Now these I'm asking you to solve for what? X. So now I'm solving for x, so let me isolate that x. Now I don't want to isolate the 2x, all I say is isolate x. So I have to eventually get rid of that 2 in front as well. Now you're going to do it the same way. So we're going to draw our river. Cool. Now, excuse me. Now, looking here, I have a 2 that's multiplying x, and then I have a negative 2y that's subtracting basically. So first thing, I want to start from the outside and work my way in. Start from the outside and work my way in. My x is on my left. I want to move everything to my right. Cool. Okay, so I want to start with this negative 2y. So how do I move that negative 2y over? I have to add it because it's being subtracted. Add 2y. Awesome. So when I go ahead and simplify, I'm left with 2x equals 10 plus 2y, right? Just write it next to each other. Okay, cool. Awesome. Now, in the other prior examples, I would be done. But I'm not done because this x is not isolated. It's not by itself just yet. So the last thing I'm going to do is get rid of this 2. But now how do I get rid of this 2? What is this 2 doing to the x? That 2 is multiplying, right? So how do I undo multiplication? I have to divide. Now if I'm going to divide by not 2x, I'm just dividing by 2. Because when I simplify, I just want x. Okay, now what you do on one side, you have to do everything. So I have to divide this 10 by 2. And I have to divide the 2y by 2. Awesome. Now, all I'm going to do is go ahead and simplify straight down. So 2 divided by 2 is 1. I'm left with x equals 10 divided by 2 is actually just 5. Now, if that was just a fraction that I couldn't divide straight down, you would just have to simplify that. Okay, good. Now, plus 2 divided by 2 is 1. So I'm just left with plus 1y or just y. Okay, cool. So now I have an answer that looks something like that. That's x equals 5 plus y. All right, so I'm going to give a money problem for number 4. Good luck. Pause the video, ask me to check it, and then you can move on to the last 3 examples. Good luck. All right, so now these are a different type of examples where you might not have a lot of numerical terms. You might have all variables or all letters or a mixture. So now it's the same idea. Okay, it's the same idea, but you're just kind of moving letters around or moving terms around with the inverse operations. So the first one, I could solve for any variable, but here I have d equals r times t. This is actually the distance formula. Distance equals rate times time. So let's solve for r. R is right there. Okay, so now basically I want a rate formula, right? So I just want to isolate it. So now you're going to look at that r. What side is the r on right now? So the r right now is on that right side, so I want to move everything to the left side. And the only thing else that's on that right side right now is that t. Now how do I get rid of that t? Well, think about it. What is that r and t doing to each other? What operations between them? What's between them right there? It is just multiplication, right? So how do I undo multiplication? I have to divide. Okay, so I want to divide by simply t, right? Because when I divide t by t, I'm going to be left with r, and I want to divide d by t. Cool. So now when I go ahead and simplify, t divided by t is 1. I'm left with r equals, now can you simplify d divided by t? You can't. So all you're going to write is d divided by t. And that's my answer. Okay, simply like that. Awesome. One more example. Okay, now I want to solve for w. Okay, so now this is going to be another type of example where I have a w and I have an l and I have an a. Right now, this is isolated for a, but I want to isolate it for w. So I want to move everything away from w. So I'm going to draw my river. The w is on the right or left right now. It is on the right, and I want to move everything to the left. Cool. So now I want to start from the outside and work my way in. I'm going to have to move that 2. I'm going to have to move this plus 2l eventually. So now which one do I want to move first? I want to start from the outside and work my way in. Okay, start from the outside and work my way in. I have to do the opposite of adding 2l, so I want to subtract 2l. Subtract 2l. Okay, so this is my number 6, so don't get that confused. So now I have a minus 2l. Can you combine them? Are they like terms? No. So you're just going to write a minus 2l. Awesome. Now, I'm going to simplify the right side. Now when I say go ahead and simplify the right side, 2l minus 2l cancels out to be 0. I'm left with 2w. Okay, last thing, we want to get rid of that 2 in front. Okay, when I want to get rid of that 2 in front, I do the opposite of the operation. This 2 is multiplying w, so I want to divide by 2. I want to divide everything by 2. Okay, so divide that by 2. I want to divide that by 2. Okay, cool. So now when I go ahead and simplify, I'm going to be left with 2 divided by 2 is 1. I'm left with w. Okay, here. Now I have negative 2 divided by 2 is actually negative 1. And you could write negative 1 if you want to. So negative 1L. Okay. Then I'm left with a divided by 2. Can you combine them? I can't. So you're just going to write a over 2. And that's going to be my answer. These are probably the most tricky, the trickiest ones when you have multiple variables and when you start simplifying, dividing out. But just remember the operation and what you're trying to simplify. Okay, here I am done because w is isolated, and that's what I asked you to solve for. All right, awesome. Okay, you have one last money problem. Now remember, you want to do the opposite operation. So this one's a little tricky, but I want to give you a challenge problem. So I want to solve for v. Where's v right now? Now think about it. What is that v doing to the m? You want to undo that, okay? You want to undo that. So you have to try to get that v somewhere up top, up here in the numerator. Okay, so think about opposite operations. So if it's dividing, you want to multiply. Okay, good luck. See you next time.